Hey, what's up? Last Layer King here. Today I'm going to be going over 3-cycle plus flip and how to use it in 3-blind. If you haven't seen my prior video on double weak swap, go check that out because you'll need to understand how to do double weak swap in order to do 3-cycle plus flip. So with 3-cycle plus flip, if you're using a UB buffer, you go into a position like this where you have shot the buffer piece to UL, you shot the UL piece to UF, and then the UF piece will be in the buffer location and flipped, and there will be one other flipped edge on the cube. So the way you'll get to a position like this is on this cube here, this piece goes to here, which goes back to the buffer, so we're going to weak swap to UL, so here to here to here. This piece goes to here, and now that we've hit the UL piece, we're going to shoot it to UF, but we're going to shoot it to the side location because we have the side location here. And now we've got our two pieces here double weak swapped, and then if we finish up edges, here to here to here, and then here to here to here, we get to the same position, which is our 3-cycle plus flip position. So with this 3-cycle, there are 9 different potential places that the flipped edge could be, and there's going to be an algorithm for each of them. So this is going to be a set of 9 algorithms, and if you learn those algorithms, you'll be able to do 3-cycle plus flip. The other double weak swap cycle that I went over in my last video was one where instead of sending the UL piece to UF, you shot the UL piece to UR, and we would get a cycle from here to here to here. In this position here, the UR piece, which is in the buffer location, will be flipped, and then there'll be another flipped edge somewhere else on the cube. This will also give a set of 9 algorithms because other than these 3 pieces here, the flipped edge could be in any of 9 locations. I'll include links to the algorithm sheets for 3-cycle plus flip in the description. I found that the algorithms for this cycle here, where you do the double weak swap on UF, are significantly better than the algorithms if you do the double weak swap on the UR piece. If you have double weak swap to UF, then the algorithms in speed are very comparable to the pure 2-flip algorithms. And for this case here, I have not found very many good algorithms, and a lot of the algorithms are longer, and I just simply have not been able to generate very good slice move algorithms for this set of 3-cycle plus flip. And in fact, I haven't even learned all the algorithms for this 3-cycle plus flip case. I would just do the flip and then do the cycle. So I don't find 3-cycle plus flip for this cycle to be very useful, but it is very useful for this cycle. If your buffer is UF, then the way you would generally double weak swap is you would put the buffer piece in UR, and then you put the UR piece in UB. And this will give you a scenario where for 3-cycle plus flip, you will have the piece in the buffer flipped and then some other piece flipped. And then same for the other cycle where you shoot the buffer piece to UR, and then instead of shooting UR to UB, you shoot it to UL. You'll still have the piece in the buffer location flipped, as well as some other piece on the cube. I've also included the algorithm sets for the UF and UFR buffers for 3-cycle plus flip in the description. Now that I've gone over the concept and the algorithm sets, let's do some example solves. So here we've got buffer to here to here, and now we've hit the buffer piece, so we're going to shoot it to UL to set up weak swap, so we'll go to here to here, and now we've hit the UL piece, so we're going to double weak swap it to UF. So this is going to go to here, which goes to here, which goes to here, and now we've hit the UF piece, and because we hit the red side rather than the yellow side, we know there's a flipped edge, and that flipped edge is here. So we've got buffer to here to here, 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 with a flipped edge here. I will now solve corners. So now going through edges, we had here to here to here, and then we had here to here to here. So now our buffer piece is weak swap to UL, and then we had buffer to here, which now sends the UL piece to UF, and then we had buffer to here, and then we had buffer to here, And now we have our 3 cycle plus flip case, which we can solve with this algorithm. Here is our next example solve. So for edges, we've got buffer to here. This goes to UL, but we've noticed that the buffer piece is already in UL, so the buffer piece is really pseudo-solved. So we can go straight into double weak swap and send this piece to UF. So we've got buffer to here, which goes to here, and now we've hit the UF piece. And we're not done memoing, so we've already done our double weak swap, so we're just going to cycle break. So I'm going to cycle break to here, which goes to here. This goes to here, this goes to here, and we finish the cycle. And there happens to be a flipped edge right here. So we've double weak swapped to UL and UF, and then we've got a flipped edge, so we'll be able to do 3 cycle plus flip in this solve. So now solving corners. And now doing edges, we had here to here to here. And now we already have our double weak swap set up with the buffer piece in UL and the UL piece in UF. We had here to here to here. And then we cycle broke to here to here. And then we had here to here. And then we had here to here, which finishes the cycle. And now we have a 3 cycle plus flip case with where the flipped edge is over here. There is an interesting application of 3 cycle plus flip in solves that have parity. So suppose we're doing our solve and we hit the buffer piece, but we happen to have already memoed UL, so we can't weak swap to UL. And suppose we've also memoed UR, so we can't weak swap to RU, like we would normally do with weak swap. What I would do is I would weak swap to UF because I've learned all the UB-UF swap parity algs so that I'd be able to force a UB-UF swap and do advanced parity. So say I've got my buffer piece in UF and then there happens to be a flip here. One way of solving this would be to just do the flip alg, which will now give me a UB-UF swap, and then I can just do the UB-UF swap parity alg like this. However, there is an alternative way of solving this, and we can do that with the 3 cycle plus flip alg. So if I do the same 3 cycle plus flip alg that would cycle here to here to here plus do this flip, this is actually going to give me a UB-UL swap. And now that I have a UB-UL swap, I'll be able to do the regular parity alg. So does this have any advantage over doing the flip alg and the UB-UF parity alg? Well, if you compare the algorithm sets, you'll find that the 3 cycle plus flip set for this cycle here is almost just as good, if not slightly better, than the pure 2 flip alg. And then you'll find that the regular parity alg is going to be better than the UB-UF parity alg. So I have found doing 3 cycle plus flip in those parity cases to be marginally better than just doing the flip alg into an advanced parity case. So now let's do an example solve where we can do this 3 cycle plus flip when we have the UB-UF swap. So we've got buffer to here, which goes to here, which goes to here, and now we've hit the buffer piece, and we can't weak swap it to UL because we've memoed UL. We can't weak swap it to RU because we've memoed RU, so we're going to weak swap it to UF. But because we didn't hit the top sticker, we're going to shoot this to the side. So this will go to FU, which goes to here. This goes to here, And now I know there's a flip somewhere because I should hit the UF piece, but I hit the other side, and there happens to be a flip here. Now solving corners. And I'll have one corner target left because this solve had parity. And now I'll do edges. We had buffer to here, and then we had to here, and then we had to here, and then we weak swapped this piece to UF, so we went to here, to here. And then we had to here to here. And now we've got this swap, but this piece is flipped and this piece here is flipped. So I'll do the 3 cycle plus flip alg. And now I've got the UB-UL swap and I can just solve parity normally. Now there's actually another parity set where we can take advantage of 3 cycle plus flip if there happens to be a flipped edge. So here we've shot the buffer to RU and we have this UB to RU swap. Normally this piece should be misoriented, but it is not misoriented because we have a flipped edge here. And the way we could solve this would be to do the 2 flip. And then we can just do the advanced parity alg where we'll just do an S-move setup into regular parity. That'll solve the cube. But we can also solve this with a 3 cycle plus flip. So if we remember in the other 3 cycle plus flip, if we did our first weak swap on UF, then if we cycled buffer to UF to UL while doing the flip, and then we get a UB-UL swap. Here our first weak swap is on RU. So let's take a look at what happens if we have a 3 cycle plus flip for buffer to RU to UL. So I'm just going to do that cycle. So we have buffer to RU to UL, and I'm just going to flip an edge. Now if I do a Y prime rotation, we now have the piece in the buffer location flipped. Our buffer piece, which is now the green piece here in this case, is in the UL location, and the UL piece is in the UF location, and we have a flip. This is exactly the same as the 3 cycle plus flip case for our original double weak swap cycle, where we had buffered to here to here. So in this case here, if we do a U prime, we can just do the 3 cycle plus flip alg like this. And we get to cancel one move. The same concept goes here, where we can do the same 3 cycle plus flip set, but just do a U prime setup. So I'm going to do the 3 cycle plus flip for this, except I'm going to start with a U prime. And instead of finishing with the U2, I'll finish with a U prime. And this gives us a UB-UL swap. This is definitely much more difficult to do than the UB-UF swap for parity, and it is certainly not going to be as useful. So you will have to do an extra setup move, which sometimes will cancel out, sometimes it won't. So the 3 cycle plus flip isn't going to be as good, and it may be faster to do a 2 flip. And then the advantage you get from getting regular parity over the advanced parity with the UB to RU swap is a bit less. So I don't recommend this set as much as the UB-UF swap 3 cycle plus flip, but it's a good thing to know. But I just found that really interesting that you can still do 3 cycle plus flip for this UB to RU swap to get a UB-UL swap. Now let's do a quick example solve where we do the UB to RU swap and do a 3 cycle plus flip. So we have buffer to here, which goes to here to here. And now we've hit the buffer and we've already shot to UL, so we're going to weak swap this to RU. So we hit the side color, so we have to shoot it on the top so that the piece is misoriented. So it's going to go to here, which goes to here, which goes to here, to here. And normally we should hit the side color because we weak swapped to the side, but we didn't. So that means we have a flip, and the flip happens to be right here. So now solving corners. So we got one corner target left, so I'll go on to edges. So we had buffer to here to here. And then we had to here to here. And then we had to here to here. So now I've got our buffer pseudo-solved in RU. So now we had to here to here. And then we had here to here. So now we got the buffers solved in RU. We have this swap here, and then we have this flip, and we've got a parity target. So now I'll do the 3 cycle plus flip for this case, except I'm going to do a U prime setup. So for this specific case, the first move is a U, so the U prime is actually going to cancel. So I'm going to skip the first move and just go into the alg. And now I have to undo the U prime setup with a U move. And I've got a UBUL swap. So that is it for 3 cycle plus flip. The main purpose for 3 cycle plus flip would be in the case that you did a double weak swap and shot the buffer here and the UL piece to here. But there are some applications for cases where you have parity, and those are kind of some more advanced applications. But the same algorithm set can be used for both of those scenarios. So I hope you enjoyed this video. Stay tuned for more, and I will catch you in the next one.